Hey everyone, today we are kicking off Unit 6. We've got our first lesson, which is relationships between quantities. And all of Unit 6 is really focused on equations, some expressions, and some inequalities that we'll get to. For today, we've got a few word problems and situations to look at. Some are very similar to what we talked about back when we were doing proportional relationships. But what I think we're going to find is that they're not proportional relationships. So remember, a proportional relationship follows a pattern. Um, so what you pay for one of those items costs the same for each item as if you were to buy 10 items. But that's not always realistic in the world. A lot of times, if you buy more of something, you get it for a lower price. And so we're going to take a look at that today. Now, our first problem is talking about pricing movie theater popcorn. Uh, Hopefully, all of you remember what a movie theater is. It's probably been a while since you've been to one. I know it has for me. Um, and I know that our labels here copied pretty terribly. So, what we have in the first column is the volume of popcorn. We'll just call it PC popcorn. We've got the price of a bag of popcorn, and that's a proportional amount. And then we have in the second column a price that's not proportional. So please add those labels to your columns. Again, I'm sorry I didn't copy quite right, but here's what we're going to look at. So this is in ounces. So we have a 10 ounce, abbreviated with OZ there, a 10-ounce bag of popcorn costs $6. And now what we're going to do is we're going to look first at proportional pricing. So the first thing we could do is we could figure out what 1 ounce of popcorn costs, because that would be a unit rate. And remember, we can always take the price divided by the number of things we're dealing with. And in this case, it's 10 ounces. So 6 divided by 10 is 0.6, 6 tenths. And that would mean that 1 ounce of popcorn, 1 ounce is 60 cents. So we'll write that out here. All right. Now, if that's the case, and honestly, just looking here, I can see that if 10 ounces cost $6, then if we double the size, we should double the price so that 20 ounces of popcorn will cost $12. And 35 ounces is now getting from here to here, getting 3.5 times bigger. Same is going to happen to my price. Or I can take the unit rate, the 60 cents per ounce, and just multiply it by 35. So 35 times 60 cents is $21. Now, lastly, I do the same for 48, excuse me, and I'm going to multiply that by 60 cents again to get a price of $28.80. Now, those are all proportional prices, but if you went to an actual movie theater, you would not see proportional prices. Usually, the largest size is going to seem like the best deal, and that's the whole point. They want you to buy the most popcorn and pay the most money, even though you're getting way more popcorn for that price than you would be for a smaller size. So, this is kind of up to interpretation, but a non-proportional price would be, say, these smaller sizes here are going to kind of increase almost proportionally. So if it's proportional to pay $12 for 20 ounces, maybe they would cut you a little deal and you'd say a price around $11. All right, so you might think, okay, well, I'm getting more popcorn. I'm not paying quite twice as much for the popcorn. Maybe you get that much and share it with somebody. Anyways, now we're going to do the same thing here, but we're going to start to really make it a good deal to try to entice the customer to buy the bigger size, to spend more money, because popcorn's really cheap. So they might now, instead of, so now we're going from 10 to 35 ounces. We're more than 3 times the size of this. Proportionally, it should cost $21. But they might say, you know what, if you get this size, you'll spend $15. All right, that seems like a great deal. If you spend $4 more, you get almost twice the amount of popcorn. And then they might even go a step further here. So the biggest size, they might really increase that just by a couple more dollars, say $17, $18. Let's say $17 because that's where they want you all purchasing. You feel like you're getting the best deal, you're getting the most popcorn for the least amount per ounce, but really you're coming to the theater and spending the most amount of money here. Okay? Now let's look at the state park entrance charges. And this relates a lot to a problem we did a couple units ago with proportional relationships. But a state park charges an entrance fee based on the number of people in the vehicle. Entrance fee based on the number of people. A car containing 2 people is charged 14. A car containing 4 is charged 20. And a van containing 8 is charged 32. Okay, now this isn't proportional. If it was proportional and 2 people come in for 14, then 4 people, twice the people, double the people, should cost double the amount of money. It should be $28, but it's not. So, first thing we need to answer, how much do you think a bus containing 30 people would be charged? Okay, well, we could certainly create a table for this. I'll just make it here in the space we have. And we have people and cost. So we know that 2 people cost $14, 4 people cost 20, 8 people cost 32, and 30 people is what we're trying to find here. All right, now if this was a proportional relationship, it'd be easy. We would just divide one of these ratios, figure out our constant of proportionality, and multiply it by 30, but that's not the case here. So let's look for some patterns. If we go up by 2 people, we increase the price $6. So we went up 2 people and we increased $6. Now what that tells me is that each of these people cost half of what was charged here. So one person would cost $3. That's kind of my hypothesis here. One person equals $3. Let's see if it holds true. So here, if we increase 4 people, and each of those people were to cost $3, 4 people at $3 would be a total of $12. So did this increase by 12? Yes, it did. So that is correct. So knowing what each person costs, now there has to be another charge here, and it's a charge for the actual vehicle. So that's what we need to find here. So if 2 people, let me change colors here. If 2 people cost $14, and 2 people, we know, because of the per person cost here, 2 people should only cost $6. So 6 of these dollars is for the 2 people in the car. The rest would be for the vehicle. So 14 minus 6 is 8. That means that there's a $8 per vehicle charge. And we could check that with the next one here. 4 people cost $12. Take away the $12 from what they paid, that leaves $8 again. It's consistent. So they're paying $8 for the vehicle, $3 per person. So how much would a bus containing 30 people be charged? Well, assuming that they're charged the same $8 vehicle fee, we would take the $8 plus the 30 people each being charged $3. 30 times 3, that's $90. So in total, 90 plus 8 tells us what that bus should pay, $98. If a bus is charged $122, how many people do you think it contains? Okay, well, we can basically mirror this. We just don't know a couple of things. We don't know how many people. So the 30 is no longer going to be part of our equation, but let's write an equation. So we know they pay $122. We know that they're going to pay $8 for the bus. And I'm just rearranging my equation because this is addition. I can write it in any order. So I'm going to add the $8 for the bus. Then I'm going to add $3 for every person on that bus, which I'm not aware of. So I'm going to use a variable. If I write, 3x, that is $3 for every person plus the $8 fee has got to equal what they were charged. Now I just need to solve it. So just like we were solving one-step equations, two-step equations are the same. I'm kind of out of room here. Let's see, I could write over here. So I'm going to transfer this down here. Remember when we solve equations, we do the inverse and we balance it. So the inverse of adding 8 is subtracting 8. Let's take away the cost of that vehicle fee. All right, those will cancel out. And now I'm left with 3x. Let me split the sides of my equation here. 3x is equal to what the bus paid minus the $8 vehicle fee. So we are at 114. Now I'm going to divide this $114 by $3 because that was what's going to be the cost for each person on that bus. It's going to tell me that x equals let's see here, x equals, I need to find it real quick. 114 divided by 3 is 38. 38 people would be on that bus. All right. Now, lastly, it says, what do you think the rule for the state park uses to decide the entrance fee? We just talked about that. It's right down here. It's $8 per vehicle and then $3 per person. And that seemed to hold true through all of the examples that we looked at. So let's continue on. Now we're talking about making toast, and a toaster has 4 slots for bread. Once the toaster is warmed up, it takes 35 seconds to make 4 slices of toast. Important information there. 70 seconds for 8 slices of toast, and 105 seconds for 10 slices. How long do you think it would take to make 20 slices? Okay, well, we should be able, it seems, to just look at this as a proportional relationship, but it's kind of tricky how it's actually worked out here. So if we were to think, well, 35 seconds for 4 slices of toast, well, let's divide that ratio. Let's do 35 divided by 4. That's 8 3/4, 8.75, which means that 1 slice of toast would take 8.75 seconds. But here's the thing. If it's a toaster, and if you can picture the toaster at your house, whether you put 1 slice or 2 slices, or if you have a big toaster that takes 4 slices, it's going to take the same amount of time to toast. The toaster doesn't care that there's only 1 piece of bread in there because it's toasting all 4 slots all the time. So if 4 slices of toast are 35 seconds, it makes sense that 8 slices would be twice the amount of time because you would have to run the toaster 2 times or 2 cycles. But when we go to 10 slices of toast for 105 seconds, really what we're doing here is it would be the same amount of time if we did 9 slices, 10 slices, 11 slices, or 12 slices, because any amount of 4 that increases is going to take another 35 seconds. So what we have to do is figure out with the 20 slices of bread is how many cycles of the toaster would we have to run? So what's 20 divided by 4, the number of slices? So 20 divided by 4 tells us that we would have to run 5 cycles of the toaster. And this right here is what a cycle of the toaster would take, how long it would take. So we would take the 35 seconds for that cycle times the 5 cycles that would have to be done. And that would tell us that it would take, so this is 5, let's see here, 35 times 5. That would tell us that it's going to take 175 seconds to toast 20 slices of bread. Now, if we look at the next part, if someone makes as many slices of toast as possible in 4 minutes and 40 seconds, how many slices do you think they can make? Okay, first problem. All of our information has only been in seconds so far. So the first thing we should do is convert 4 minutes and 40 seconds into a total number of seconds. So 4 minutes, each minute is 60 seconds, so let's multiply that by 60 to get 240 seconds. Don't forget about the 40 seconds also. So we're at 280 seconds. That is our time frame here. Now we know the time it takes to run a cycle on the toaster is 35 seconds. So let's figure out how many 35-second intervals or cycles that toaster can run there. So we'll take 280 divided by 35, and that equals 8. We still haven't answered our question, so be sure you know what we're trying to answer. How many slices do we think we can make? This was how many cycles the toaster can run. Now, if it's a 4-slot toaster, then we, in each of those cycles, should be able to toast 4 slices of bread. So let's multiply that by 4, and I think we should be able to toast 32 slices in that time. Okay, back to popcorn again. So for this question, and we're getting close to the end here, for this question, again, the labeling on that graph was terrible, but it's the same labels as before. So this is the price, this is the volume, or the size of the bag, and that's in ounces. So we have 10 ounces here is our first example for $6. Now it says, a movie theater sells popcorn in bags of different sizes. The table shows the volume of popcorn and the price of the bag. If the theater wanted to offer a 60-ounce bag of popcorn, what would be a good price? This is all kind of reasonable and estimated to answer this type of question because it's not going to be a proportional relationship. If I divide $6 by 10, I am not going to get the same unit rate as 8 divided by 20. This is not a proportional relationship. So let's look for some patterns. So here in the first 2 rows, we double the amount of popcorn and we've increased the price $2. All right. Now if we look here, let's jump. We've gotten almost 5 times bigger, and the price has gone up. Let's see, almost $8, about $7. So if we were to go to a 60-ounce bag of popcorn, and let's look at these increments that it's increased here in price, because this is all going to be up on the menu board. We don't want it to seem like too big of a jump. We want people to buy that big bag of popcorn. So this has increased $2. This has increased $3. This has increased $2.60. So for this next increase, we should go up probably about $2 or $3 to stay consistent with that. And let's say we want people to buy it. Let's go up $2. Well, yeah, maybe 15 or $16 would be a reasonable price. And this is all just kind of based on what we're seeing in that menu. So we're trying to keep kind of a consistent where we want the customer to purchase this larger bag of popcorn and spend the most amount of money at the concession stand. Okay, I know all of this is kind of um, not necessarily always following rules, it's doing some interpreting too. And that's okay. Sometimes we have to do that. Um, let's look at this last situation. I'm going to quickly explain it, and then I want you to continue it. The directions explain what to do, but it says write and solve an equation for each set of clues below. So they give you the word form, or what they're calling the problem, and we need to write an equation for it. So this is going to be really key with your vocabulary. 2 less than a number is 10. To write that into an equation, and these equations are all going to have variables in them. First, I would kind of recommend, like yesterday, let's find that thing that we're missing. So less than a number, that's our variable. You can use any variable. We'll use x here. 2 less than a number is taking this number we don't know and subtracting 2. But be very careful. If I wrote 2 minus x, that's something very different. So we have to go very carefully based on the wording, and look how it's kind of backwards here. Because to get 2 less than a number, we need to take that number, drop that value by 2, and then we're told it's equal to 10. So now I need to solve it. Remember, inverse and balance. So the inverse of subtracting 2, the opposite of subtracting 2 is adding 2. So we add 2 to each side of this equation, and x is equal to 2 more. X is equal to 12. That would be my solution. We'll do another one here. Let's see here. Oh, now, so we have to be very careful how we solve this because our solution is going to tie into the next situation. It says the product of three times a number equals the answer to problem 1. All right, so we're going to take our problem to number 1. We're going to use the product, multiplication here, of 3 times a number. There's our missing value. So 3 times a number, 3x, equals the solution from before, 12. Okay, we'll do the inverse. Instead of multiplying everything by 3, we'll divide by 3, and we'll balance it on each side of the equation. 12 divided by 3 is 4. So x equals 4. And that's going to continue into the next problem. Okay, go ahead and finish this table. Take a look at your practice problems today. And again, reach out on Zoom if I can help. Have a great day.